Hi, Assalamualaikum warahmatullahi wabarakatuh. Today we will be presenting about our assessment 2, which is assessment STA 568, and we are from N4 CDCS 241431. Let's move to the group members, and as you can see there, my name is Muhammad Haris Hakimi bin Zaidi, and my friend is Muhammad Huwas Al-Kholmi bin Hashim. Today we will be answering the task given by our lecturer.
Assalamualaikum and hi. I am Uwais, introduced by my friend Haris. So, for the question, which is question 12, let x1, x2 up until x10 be an independent random variables from a population with the following probability density function, with the function of s is equals to e to the power of negative x squared over 4 theta over 2 square root of pi theta, and the interval and the range is negative infinity up until infinity. So we will go through all 4 questions with question A, B, C, and D. So for question A, find and state the distribution for y equals to x squared using the method of transformation. So we need to make the x as our subject. So we will square root both sides and we get x is equals to plus minus of square root of y. So the first step is we need to make an inverse functions, which is we have plus and minus for the square root of y. So the x1 is equals to square root of y and x2 is equals to negative square root of y. So the next step, we need to differentiate the inverse functions where xi are equals to the function of wi y. So now for w1 y is equals to x1 and w1 and x1 is equals to square root of y. So we differentiate wy and we get 1 over 2 square root of y. So next, for the next function, which is w2y, which is equal to x2, and we get negatives of square root of y, and we differentiate, we will get negative 1 over 2 square root of y. So next, for the third step, we will substitute the values we gathered into the gy, and in the first part of the formula, we need to substitute the values of wy into the original function of the question. Meanwhile, on the second part, we need to modulus the inverse function of wy. So we will get 1 over 2 square root of pi theta multiplied with e to the power of negative square root of y, and we square it over 4 theta times 1 modulus of 1 over 2 square root of y plus 1 over 2 square root of pi theta multiplied with e to the power of negative and negative again square root of y, and we square it over 4 theta times modulus of negative 1 over 2 square root of y. So next, we will factorize the exponential, and next we will cancel out the 4 and the 2, and finally we will get 1 over 2 square root of y pi theta multiplied with e to the power of negative y over 4 theta. So the probability density function we'll get is gy is equals to 1 over 2 square root of y pi theta multiplied with e to the power of negative y over 4 theta, and interval is y is greater than 0. So the PDF we get can be converted into the gamma distribution, which will get y implies gamma 1 over 2 for theta, which is also equivalent to the chi-squared, which is xi squared implies 2 theta x1 squared.
So for question 2, we need to find the moment generating function for w, where w is equals to summation of chi square I over 2 theta, and we need to use the information in part A to answer this question. So from part A, we show that the summation of chi square I over 2 theta is implies chi square 1. So for each I value, it starts with 1, 2, 3 until 10. So since our x1, x2, x3, x4, x5 and until x10 are independent, the transform variable chi square 1 over 2 theta, chi square 2 over 2 theta and until chi square 10 over 2 theta are also independent. By using the W value that given in the question, we will be using theorem 2.4 and we will get the W implies chi square 10. And by using MGF formula for gamma distribution, which is 1 minus 2t power of negative v over 2, we will answer this question. So first of all, we need to substitute the v value, which is 10, and the v value is our degree of freedom. So after substituting the v value into the formula, we will get our moment generating function, which is 1 minus 2t to the power of negative 5 and t less than 1 over 2, and that is our moment of generating function for this question. For question C, we need to construct a 100% of confidence interval for theta, and in B we already show that W is equals to chi square I over 2 theta implies chi square 10. So in this question, we will use the chi square probability statement for a chi square random variable with 10 degrees of freedom, and the formula that we will be using is fixed for this question, and we need to memorize it because we will use it again and again. So first of all, we need to substitute the W value in the formula. So our goal here is to let the theta be alone in the middle. Okay, after we move the variable left, right, up, down, and finally we already achieve the single value of theta in the middle. So that is our goal. So we already achieve our answer. So our last answer for this question is summation of chi square I with degree of freedom 10 over 2 chi square 10 alpha over 2 comma summation of chi square I with degree of freedom 10 over 2 chi square 10 and 1 minus alpha over 2, and that's it to answer this question.
So for the final question, which is question D, determine and explain the difference between 95% and 90% confidence interval for theta if the sum of SI squared is equals to 500. So we will start with the 95% first, which is the alpha value is equal to 0.05. We will substitute the value of the sum of chi squared and the alpha into the second part, which is for the chi-square value with a degree of freedom of 10 and the alpha value of 0.025, we get a value of 20.283. While for the chi-square value with a degree of freedom of 10 and the alpha value of 0.975, we get the value of 3.247 from the table. So we divide 500 over 2 times 20.283 and we get a value of 12.2052. While on the other side, 500 divided by 2 times 3.247 and we get a value of 76.9941. So the data will in between 12.2052 and 76.9941 for 95% confidence interval. So next, for the 90% confidence interval with the alpha value of 0.1, we will substitute the value of alpha and the sum of chi-squared into the second part of the solution. And for the first chi-squared, which with the degree of freedom of 10 and the alpha value of 0.05, we'll get a value from the table, which is 18.307. While on the other side, for chi-squared with the degree of freedom of 10 and the alpha value of 0.95, we get the value from the table, which is 3.940. So 500 divided by 2 times 18.307, we will get the value of 13.656. While on the other side, 500 divided by 2 times 3.94, we will get the value of 63.4518. So theta will be in between 13.656 and 63.4518. So, comparing the two values of the intervals, the 90% confidence interval has a smaller width at 49.7958, indicating greater accuracy but less confidence. In contrast, the 90% confidence interval has a larger width at 64.7889, indicating less accuracy but more confidence. So that's all for us. Thank you.